What is going on, everybody? Welcome back to another video of Cup Code 01. Let's jump back into Numpy. So today, another day of Numpy. So let's get into it. First challenge. Find the number of elements of an array, length of the array in bytes, and total bytes consumed. So first off, we're just importing NumPy as NP, creating a variable x, in that variable np.array, and then the array is a function, and then we're putting in the actual array that we want to use, which is 1, 2, 3. And data type I'm making into an np.float64. This will be important in a second. Use 64, you divide it by 2, you get 32. Go further down, you'll get 16, or even below that 8. So we have 8-bit, 16-bit, 32-bit, 64-bit. 128-bit is not yet there. What that all means, I'm not going to get into today because it's not a computer science class, but the data type object that I have here, D type stands for data type. You've seen this before when I've done D type equals int, when I wanted the output to be an integer format. So here I'm saying I want the output to be from NumPy float 64. So again, see I have a data type object from NumPy.dtype is the class. So the class data type tells us how bytes in a fixed size block of memory are corresponding to an item in the array should be interpreted. So we're telling the computer how to interpret the bytes that are within that array. And that array that we created was array 1, 2, and 3. So again, I have here in terms of the data type using the class dtype, we can call either int, a float, or an object, size, how many bytes we wanted to do it as, byte order of data, and more. We're not going to get into all of that. The float 64 refers to floating points. So you're going to, even when we get into GPUs, you'll have single point, double point precision, and so forth. But the float 64 is how many floating points that we're going to have in the format for the memory corresponding with the actual bytes that we're putting in. So 64 tells me it's double precision floating point format. Higher the number, the more space it's going to take in the memory. One of the ways this is why when you're downloading programs, if you have a 64-bit system, you want it because it can utilize more of your RAM. If you get the 32-bit instead of the 64, you can't use all of your RAM, or you can't use the RAM that you want to allocate to it. So with all that being said, we want to print the size and then x.size. That's going to give me the size of, again, this x element here. Size was a string of length of one element. We want the item size and we want the n byte size. So this dot n bytes dot item size dot size are all different classes and methods that are tied to NP array. And again, that was the type that we were calling was the floats. So we're going to pick this up and we're going to run this bad boy in our console. And we get the array that we created is a size of 3, and that's true. We have 1, 2, and 3 different elements in it. Length of one element, we have 8. Total bytes consumed, 24. So that's saying that one element was 8 bytes, and then, 8 bits, and then 24 bytes in total with the total bytes consumed. Now, if I would have made this, look at me trying to change code in the console. If I would have made this 32, now we had better get a different execute in the console. We better get a different output. Now we get 3, 4, and 12. So you can see it's already taking up less memory. 3 different elements. Each element's taking up 4 bits and a total of 12 bytes altogether. So changing up your, oh my God, I'm doing it again. Changing up your byte size is going to have a substantial impact on memory. Let's execute you in the console, and now we're getting 3 elements again, always 3, and that makes sense, right? Because we have 3 in our array that we created. Each one is taking up 2, so a total of 6. So we went with a 64-bit, we were taking up 24 bytes of memory. 32 was taking up half of that, 12, and then the 16 was taking up half of that, 6. So the point of that is that, of course, if you're ever doing computing or writing software and you want to be gentle to the memory, you might want to be changing how your data type is being stored within memory. Sometimes you don't need as much as you think you might be calling for, and that can have a big impact on the program that you're running. So we did this. We changed our float to 32 to 16 just now, just to see what was going to happen while we were playing with the code. In this next spot of code here, I wanted to, just going to rearrange this a little bit here for you guys. Okay, not like that. I wanted to show sometimes the naming doesn't even matter. As long as you're calling the appropriate library, you can name things whatever it is, tickles your fancy at that moment. So here the challenge is test whether each element of a one-dimensional array is also present in the second array. So I have import numpy as pumpkin. Again, it doesn't matter what you're going to name it as long as you're consistent when you're calling it. So array uno equals pumpkin.array, and then I created an array within the function of pumpkin, which is being called from numpy. That's how we're calling numpy in this particular code. Array dos, so I have two different arrays, two different variables that are going to be arrays. Pumpkin.array 0, 40, 50. Now I have print pumpkin.in1d. That's what that says, in1d. And then the two arguments are array uno and array dos. So all I did was within this function here I'm calling within the print function, I'm calling from numpy in1d, compare these two different arrays and tell me which is present in the second. So we're going to run that, and then we'll compare it to our code. Let me bring you... So it's telling me in 1D, just want to get rid of that green. If you look at our two arrays here, we have them here, and we got a true, false, 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 true, true, false. So all we did was we're comparing two different arrays and seeing in 1D is part of the two in array number 1, or array dos if it is in array uno. So I go to 1 and I go 0, 0, true, it's in there. 10, 40, false. 20, 50, false. 30, anywhere in here, false. 40, anywhere in here, true. 50, anywhere in here, true. And lastly, 60, anywhere in here, false. So that's all that was doing. And again, I know this might seem silly, but these little pieces, these little functions like this part here, this one in 1D, have a lot of importance and help later on as we're creating different programs, especially when we're creating different video games or different emulators for games to run different programs on. So we want to find common values between arrays. So now we're going to find what are the common values between two different arrays, and that's what I want as my output. So I'm going to import numpy as Scooby-Doo for this one. I have taco, that's my variable, equals Scooby-Doo.array, and then all we did was create our array. Scooby-Doo underscore snack, that's what I'm calling this variable, equals Scooby-Doo.array 10, 20, 70. And then I'm having print taco, I want a new line, that's what that is there. So print taco, so we're going to print this array, new line, Scooby-Doo snack, it's going to print this array, new line, Scooby-Doo dot intersect 1D, and then I'm comparing Scooby-Doo snack to taco. So now let's see what it's going to give us. This one's going to tell me the common values between arrays. So this is now we're looking at the here we go, the function of intersect in 1D. So out of it gave me 0, 20, 40, 60, 80, 100. That's my taco. And then 10, 20, 70. 10, 20, 70 is my Scooby-Doo snack. And between when it says intersect of 1D, Scooby-Doo snack and taco, there's only one value it's returning that's common to both of them, and that's the 20. So I can see that that's working as well. Last part for today, we say the challenge is rock the opposite. Find the unique elements. So importing numpy as n, just again, I'm only calling it again because I'm renaming it. X equals n.array, I created an array here. Print n.unique x, and here the x, the argument, is what we're calling the array that was created. So this should be pretty simple to understand. We're saying give me the unique elements that are in this. So here I have a 10 and then a 10. So one of those is unique, one of those is repetitive. 20 should be unique, it's the only one that's in there. 30, one is unique, one is repetitive. 40, one is unique, and there's no other ones. 50, one is unique, one is repetitive. So when I run this, execute in console, we get 10, 20, 30, 40, 50. And that's appropriate. That gave me the unique values that are in the array X that we created. And then lastly here I have y equals n.array. What I did was I wanted you to see these double quotes. Quotes, and then it's here, the double brackets. So we have 1, 2, 3 individualized arrays within the main array that we're calling. And we want to find the unique elements in the arrays. So in this first 1, 1, only number 1 is unique. 2 and 3 are unique to the whole system, so 2 and 3 get pulled. And 6 is unique to the whole system, so number 6 gets pulled. So this has created a new array that was pulling from the unique function, pulling out the unique portions of that array. Again, nothing too mind-blowing as of yet, but just building the foundational work for when we get into our more fun expeditions. So with that being said, everybody have an excellent evening, and I will talk to you tomorrow.